Hi everyone, my name is Wojtek, and I work at Dolby Labs in Wrocław. And today I'm going to talk about a bit of some strange plants like cucumbers and gherkins. You will learn more during the presentation, but before I get into the presentation, I would like to explain briefly why am I talking about this topic. So, as Gosia mentioned, I used to be a writer, and I wrote mostly in Data XML. I started to get more and more interested in topics of automation, and there's a lot of automation opportunities in technical writers' work. So I started to work in XSLT, XQuery, and Schematron, and I found out that actually it gives me a lot of joy, a lot of fun. So why not taking it further and learn some more new things, some more automation? And I became a QA engineer at Dolby, where I focus on software and hardware testing. I started to learn Python, and I also work with CI environments, which allow to build software automatically and run tests automatically. But nevertheless, I still do a lot of writing, and I still support the documentation team. So I like to get back to what Rafał said, that it's a cool thing that everybody writes, and even if you change your focus from not being a technical writer to another job, you will still do a lot of writing. As a QA engineers, we still create a lot of test documentation and other documentation. So there's still a lot of opportunities to write. When I started working on this presentation, I promised myself I won't do any of the three things. The first thing I said I won't put into my presentation are some famous quotes from more or less famous people. The second thing are charts that sometimes bring meaningless information and are not really showing the real goal of the presentation. And the third thing are some pseudo-funny pictures that everybody has seen somewhere in thousands of versions. So here we are. Life is perverse, I guess. So basically, I guess the goal for showing this picture is that a lot of things that happen with our software, with software that we produce, and the fact that it's not really designed well is a problem of communication and not discussing your expectations properly. So, yeah, charts. So these charts show. These charts were done in US based on 50,000 companies by a Standish group based in US. It comes from the Chaos report from 2015, and it shows that only 29% of IT projects were actually finished on time and within budget. And from this 29%, features that were initially proposed, only 42% of these features ended up in that software, in that project. And from these features, only 45 features were delivered into production, and they were never used. So, yeah, a quote. So, but I like this one. It's always either one of these two things. You're either not building the software right or not building the right software. That's why the problems happen, and that's why we have such statistics. So now getting back to the main topic of my presentation, here are some definitions and some things that we are going to talk about. So first thing is test-driven development, which is basically a software development process, and I will have another slide about that in a second. But this is the basis of the behavioral-driven development, which is more or less the topic of this presentation. And BDD emerged from TDD. BDD was developed around 10 years ago, and it's really a nice thing to check in terms of software development processes. So to implement BDD as your software design process, you use software tool which is called Cucumber, or you can use also Behave. There are several options. And gherkin is a language that helps you to describe features during creation of the process, and define the test cases. So how it looks like. So test-driven development, as I mentioned. This is basically the life cycle of a software design process in test-driven development. So you start reverse to what you might think is a regular type of a software development process. You start with writing a test that basically fails because there is no feature in your software yet that makes that this test can pass. Then you create the software that makes the test pass makes the test pass. And then during the process you create more and more software, you refactor the code, you adapt names of your functions, methods, you clean up the code, and then back again you write a test. So more or less this is how test-driven development looks like. And now, as I mentioned, from TDD, BDD emerged from TDD. So behavior-driven development was emerging from the TDD process. Now let's have a quick look how traditional development process usually looks like. So we have a business owner or a customer here that tells the analyst what he would like to have, what software he would like to get. Then we start writing a big document with requirements. Now, when we have the requirements, the development can start. So the developer translates the requirements into the software. Meanwhile, the tester starts to create test cases based on the requirements document. The writer works also starts somewhere here, hopefully. I mean, not at the end, but in the middle. So technical writer starts to use the requirements document and talks to software developers and software testers and creates the documentation. And that all comes into a package that we deliver at the end. So in a behavior-driven development, it looks like that. So again, business owner have a talk with a business analyst and talk about business needs. Now, all the members of the development team process, so the writer, the QA engineer, and the developer sit down together and struck down the list of requirements into something what we call scenarios in BDD, which is a really human readable test cases basically that end up being a basis for creating the software. So we have the scenarios. So developer starts to create the software and automated tests. On the other hand, the tester also uses the scenarios to create more tests, regression tests, whatever. We also use the scenarios to create documentation. And same thing as before, we end up creating a software that is delivered. So the basis for creating the scenarios and describing the feature in an agile process is usually a user story. So probably most of you are familiar with or heard about user story. It's basically looking at the feature from a standpoint of a user. So the formula of a user story usually looks like this. As someone, I want some kind of a feature to get some kind of a benefit from having that feature. And as an example, a story card which includes the user story could look like that. As a user, I want the app to show the typed text so that I see what I type. Now, this is just a reversion of the order of the story card that emphasizes the outcome at the beginning. And that helps us in creating the scenarios in behavior-driven development. So we have the business goal, which describes the feature. Now, we turn that into a scenario. So how would the scenario look like? We want, let's call the scenario typing text. Given I open the app, when I type hello world, I see hello world in the app window. That's basically a test case that checks if that feature works. Now, as you see, as I mentioned, this is really easy to understand. Everybody can look at it and say, okay, I see how that functionality works. And on the other hand, Gherkin allows us to use these scenarios in creating tests, in creating software directly from that language. So let's see how it looks like more in details. So this is again, this is the structure of the feature. So you have a feature name, you create a scenario. There can be multiple scenarios for one feature, obviously. And then you describe the context and what is the outcome of the feature. So given some context or more context, when something happens, we get an outcome. And we get another outcome. And then we have more and more scenarios that we can add to describe the feature. Another example. This is an example about transferring money from one of your accounts to another. So you want to be able to transfer money between your accounts. So in order to, so that is a user story, basically, a business goal. You want to manage your money more efficiently. So as a bank client, I would like to be able to transfer my funds from one account to another. Now, translating that into a scenario looks like this. Saying that the scenario name is transferring money to a savings account. We check that if we have 1,000 on a savings account, on a current account, sorry, and on a savings account, let's say we have $2,000, then if we transfer 500 from current to savings, we should get 2,500 in savings and 500 in current account. This is a very basic test scenario that checks if that feature actually does the thing. Now, at Dolby, we used a pilot project to check if behavior-driven development will bring us value. So we have an interoperability test suite, which basically checks on the software that Dolby delivers if a set of connected Dolby devices can handle Dolby audio properly. And that's all just software-based. So the TV or a soundbar or an audio-video receiver are basically a software binaries that are connected, and we run tests on them. So we define scenarios. This is just a snippet of the code. There's a bunch of features that we check. Then in the backend, we implement steps of these scenarios in Python. And all these scenarios match to the steps that are implemented in Python. So now anybody can look into the scenario description and understand what are we really testing and what do we really want from that particular software to happen and doesn't have to look into steps, which are written in some kind of programming language like Python or Java or whatever, anything else. So we managed to do that at Dolby internally with quite a success. So what we got from that is that in the whole chain of people involved in a software development process, everybody could understand what the real goal is. And wrapping things up and getting to pros and cons that we found from using behavioral-driven development. Behavioral-driven development helps us with making sure that we always look on the outcome and the user needs. So at all time, everybody understands what the real goal is. The description of features is human readable, is easy to understand, and anybody can look at it and understand what's the real goal of that feature is. Now, we also found out that actually writing the tests first reduces the potential bugs because you already have in mind that real functionality of the software. In the opposite way, you're never sure that if the tests really checks the functionality, or do you actually just check if the software doesn't fail in particular situation. So it's a bit opposite point of view. So a hard thing to do is to change the mindset in writing, because it requires, as I said, involving all the production chain, everybody in the software production process. And also, you kind of assume that your interface of your software will look in a particular way so that you can create test cases. But it might change in the future. So it's a bit, it's not always flexible in terms of thinking about your software and how it will look at the end. So that's all. That was brief. If you have any questions, please ask. And we can also talk about it outside.
Thank you, Wojciech. Questions?
Yeah. Hello, I'm Martyna from Wrocław. I'm an information developer, and I have actually two questions. So, as a Q&A engineer, you've mentioned that you are still dealing with technical writing. So, do you use the same tools as you used to use while being a technical writer? This is the first one. And the second one is, do you have the same or maybe different review process?
Mm-hmm. So, as a QA engineer, I mostly create internal documentation. We use Confluence to store our internal documentation. I personally use a lot of tools I used as a technical writer, but it's not really necessary. Of course, there is no. So sometimes, if the document is like highly important, or we want to show it to some higher management, for example, of course we do the review process of that. But mostly it's just for our internal documentation, so we don't really do the editor's process. Yes?
Okay, I would like to ask about that mind changing. It's I would say that it's rather the most difficult stuff around that. Who takes care of it? Who is responsible for that? Is it you? Is it management? How does it work?
So I would say collaboration again. So everybody. I mean, if everybody has to see the value of that change. Of course, it starts somewhere. So probably I would say in that case, it started from a QA engineer, from another guy that talked to some developers, presented that idea to the product owner, and they all seen the value in doing that. But this is like kind of a small internal project right now. It's not spread across, so we don't use it like in every project we have at Dolby. We don't use BDD as our thing. It is though hard because it took a lot of time to discuss, to try to implement that. People are, it's not only, so changing the mindset is not only about not being sure if that really helps. It's also about doing some additional work to adjust to new way of creation, right? And everybody has, everybody is being anxious in terms of changing to a different tool, to a different environment, to whatever. And it involves all people in the chain. So yes, it's challenging, but there is a value in that. And as soon as you can make a pilot project, for example, then it's much easier to explain that further in the management chain. Or whatever.
Any other? Okay, one more question here.
Yep.
Hi, I'm Rafael once again. I have a question about full tests. So, how you are testing the full feature? I mean, many times we have that situation that we have to check one of new functions, for example, with many data sets. And you show us that this kind of description is human readable. But what if we've got plenty of data sets to test it?
I mean, yeah, I think I know what you want to ask, but to be honest, as I said, we didn't have that challenge yet to work with a lot of tests. Let's say the features that we checked, we had like around, we narrowed down the number of features to like 6, 7, or 8. With maybe 8 or 10 scenarios in each. Basically, the scenarios were based on a previous test or a previous test suite that created in a different way, right? So we kind of used the same pattern. It's always right. If you create a new software and you have tons of requirements, it is hard. You have to walk through it. Like try to narrow it down to less and less and less. And it's probably
it can become less readable. And this is what I'm asking about. Because if you have to test some functions for what if I will send you $100, $200, what if I send you zero number of dollars? And this description that you show us probably will be some less readable then. So this is why I'm asking. But I think we can use it, Cucumber and that kind of BDD in our company. So
you should try it. It's as I say, we work on a maybe smaller data set than you have in mind. So it's hard for me like to see that right now. I mean, I know how requirements documents can look like and how hard they might be to read for everyone. And still, taking the requirements documents, you still need to create test cases which are non-human readable. So why not like combining that and trying to put that into a simple context, understandable. So. It still might be challenging, of course. It's not a solution that gives you a straightforward and it's not everywhere. It's probably will work, right? So it's not that flexible in terms of the design of the software. So because you already assume that the software will look like a particular way at the end, right? And it might change. So just give it a try, maybe, and then a smaller project.
Okay, we have one last question here.
Hi, I'm Kasia, and I'm working on Nokia as a technical writer. And I have a question: if really in this behavioral-driven development we have a place for a normal technical writer rather than a tester who creates the documentation, as you said. So, do you think that there is a place for a technical writer, or rather a tester should create documentation?
No. The goal is not to replace anybody's function right here. The goal is to have a one set of features that we want to have explained in a really easy way. And what happens on the documentation side is still on the writer side, because this is, I'm not showing, so that features is not something you deliver as a documentation at the end. You take these requirements as a writer, you walk through, and you can see in a very early phase, actually, where developers start to work, where testers start to work, what already will be in the documentation, and it will be described, right? And it's probably, even for a writer, it's easier to walk through that than try to get some development process documentation that is created by developers. Sometimes that is hard to read, and try to get information from developers. You already have a basis that is very, very easy to understand, to see what, and the scope of the, what will be the scope of the project. So it doesn't exchange the work of the technical writer.
So you're safe. Still. Okay, thank you.
Okay, thank you guys. Thank you, Wojtek.
Thank you.